A very warm welcome in the class of numerical methods. In this course, we are in the module of solution of system of linear equations. And according to our structure, in the solution of system of linear equations, we are going to learn some methods which will be distributed into two parts. First one is direct method and second one is iterative methods. Under direct methods, we are going to learn first Gauss elimination method, which is the topic of discussion for today's class. So let us proceed and see what is our target, what is the method we are going to follow, and finally how we are reaching to our destination according to this method. So if we are considering the system of linear equations, in that case, what actually we are getting? In general, we can write it as a11x1 plus a12x2 plus, if we continue, suppose I am writing it as a1n xn is equal to b1. Next line, a21x1 plus a22x2 plus a2n xn is equal to b2. In the similar manner, if I write a m1 x1 plus a m2 x2 plus plus a mn xn is equal to b. How many equations we are having? 1 2 3 4 up to m, so it is bm. Now here x1 x2 up to xn, they are our unknowns, and we are trying to find out the values of x1 x2 up to xn such that satisfied, if we are substitute them in this system of linear equations, it will be satisfying this system. That means the right hand side terms b1 b2 b3 up to bm will be achieved. Now here what we are seeing there are n unknowns, and we are getting first one, second one, third one. In this way we are getting m equations. Now there will be some relationship between this n and m. They may be equal, they may be unequal, and so on. We are not going to enter into that discussion in this particular part. I just want to say that this system, if we are taking in a smaller form, that means suppose we are taking here n is equal to m and it is equal to 3, then how we can represent this system of linear equations? So suppose I am writing it as a11x plus a12y plus a13z is equal to, suppose, b1, a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. Now this system of linear equation is having actually 3 cross 3 situation. Now for our benefit, for solving the system of linear equations, we are going to convert it into its matrix form. So let us see what matrix form we are going to get from this. So if I write a11, a12, a13, A21, A22, A23, A31, A32, A33, which is on x, y, z is equal to B1, B2, B3. If we can follow the rule of multiplication in case of matrix, we will get A11x plus A12y plus A13z is equal to B1. In the similar manner, the next two equations will be achieved. That means this is the matrix representation of the previous equation, where we can write it as Ax is equal to B, where A is our coefficient matrix, that means this one. Capital X is the unknown vector, that is this one, and capital B is this one. Now we can also have one concept of augmented matrix, where we can write this augmented matrix in this form. Generally, augmented matrix is denoted as A slash B form, and which is nothing but we can represent it like this: A11, A12, A13, A21, A22, A23, and A31, A32, A33. That means the coefficient matrix along with B1, B2, B3. So from any given system of linear equation, we can convert it into its augmented matrix form by this rule. So this is our first part, which is directly related with the conversion of the system of linear equation into its matrix form, and consequently it will be required in the Gauss elimination method. So once for a given system of linear equation we can convert it into its augmented matrix form, then what is our target? After that, our target is to use elementary row operations in this augmented matrix to convert it into its echelon form. Now I want to refer here your idea in any of the linear algebra class which you have already attended prior, where you got the idea of elementary row operations as well as you have the idea of echelon form. And those who want to revisit this one, they can visit the page where these discussions were made in this particular video lecture repository. Okay. Now, after converting it into its echelon form, then by back substitution method, we will reach to our target, that is the solution of the system of linear equations, means the values of x, y, z correspondingly we will get it. Now I will make it clear by exhibiting one problem which we will solve it by following the process what I have discussed here. So let us take the problem as x plus 2y plus 3z is equal to 10, 6x plus 5y plus 2z is equal to 30, and x plus 3y plus z is equal to 10. Now we can see that this is a system of linear equations, as well as we are having three equations with three unknowns. So if we just follow the previous process what we have discussed here, in the next line we can write it as, our target is to write it as in Ax is equal to B form. Now if I want to represent it in terms of Ax is equal to B, this algebraic system can be represented as 1 2 3 6 5 2 1 3 1 into the unknown variables x, y, z. Then we will get the vector b as 10, 30 and 10. Next, if we can recall that our target is to construct the augmented matrix, that is A slash B, then here our A slash B will be 1 2 3 6 5 2 1 3 1 along with 10, 30 and 10. Now our next target is to convert it into its echelon form. So I am trying to use this space in this slide to convert it into its echelon form, but before that I just want to mention process what I am following, it is not the unique one. You can also change the positions of these rows, but you have to restrict yourself into elementary row operations. So likewise what I am saying, you can interchange second row and third row for your own benefit, or if you feel that it will be helpful for you to calculate, and obviously you can do it. So what we are doing now, we are now converting it into this particular matrix. We are not going to change the first row, so 1 2 3 along with 10 will be there. After that, for the second row, as per the requirement of the echelon form, we need at least one 0 over here, so that in the downwards direction the number of zeros are increasing. So if I want to make it 0, so obviously I will use the elementary row operation here as R2 goes to R2 minus 6R1, so that 6 minus 6 into 1, it will become 0. And following this rule for the other elements in the second row, we will get it as minus 7, because 5 minus 6 into 2, that is 12, so 5 minus 12 is minus 7, and in the similar manner it is minus 16, and also in the similar manner it is minus 30. But parallelly, to make it echelon, we need this one is 0 as well as 1 0 will be increased. But for the initial part of this 0, we have to use the elementary row operation as R3 goes to R3 minus R1, because we are getting 1 here and 1 here, so obviously by subtracting them we can make it 0. So we will get 0 here, then 3 minus 2, that is 1, and consequently the next one will be minus 2, and here we will get 0. Till now we don't get it as the elementary row operations. After using elementary row operations, it is not in echelon form, but our target is to make it into its echelon form. So we will think for the next elementary row operation, so that this part will become 0. So what is the elementary row operation we must use to make this one 0? So the first row will be kept as it was, 1 2 3, and it is 10, as well as the relationship between the first row and second row is already satisfying the requirement for echelon form, so I am not going to disturb it. So it will be as the previous matrix, what we get as 0 minus 7 minus 16 is equal to minus 30. After that I need here 0. So what elementary row operation I have to use so that I can make it 0? I have to make R3 0. So R3 will go to R3. This is my 1. Then how can I make it 0? By using minus 7. So I can use plus 1 by 7 R2, so that minus 1 plus 1 by 7 into minus 7, that is minus 1, and it will become 0, and the effect of this 0 will remain as 0 over here. So I am getting this to 0, and following this elementary row operation we are getting it here as minus 30 by 7, as well as it is also minus 30 by 7. So in this regard what we are getting is that if I consider now this as my new augmented matrix, which is also in echelon form, so the back substitution method actually tells us that from this we can construct one matrix equation like this: a dash x is equal to b dash, where a dash and b dash are reformed by these elementary row operations. And for this case I can write it as 1 2 3 0 minus 7 minus 16 0 0 minus 30 by 7. This is my a dash. Then my x will be as it was, x y z, and my new b dash is 10 minus 30, then minus 30 by 7. Now, as we have proceeded from algebraic equation, system of linear equations, to matrix equation, now from this matrix equation we can go for the algebraic equation. So I am going for the next slide. Just by multiplying this as 1 into x plus 2 into y plus 3 into z is equal to 10, and in this form, so my new equation will become as x plus 2y plus 3z is equal to 10, and in the next 0 into x, then minus 7y minus 16z is equal to minus 30, and finally we are getting it as minus 30 by 7z is equal to minus 30 by 7. So this is my new system of linear equation, which is equivalent to the given system of linear equations. Now by back substitution, that is from the third part of this linear system of linear equations, we get that z is equal to 1. We want the value of x, y and z, and already we got z is equal to 1. Now putting this z equal to 1 in the second equation, we can write that minus 7y minus 16 into 1 is equal to minus 30, which gives us minus 7y is equal to minus 14, and which gives us y is equal to 2. So immediately I got the value of y also. And finally, putting the values of y and z in the first equation, we can get x plus 2 into 2 plus 3 into 1 is equal to 10. So in the next line I can write x is equal to 10 minus 4 minus 3, that is we get the value of x is equal to 3. And finally we have reached to our target, that we got x is equal to 3, y is equal to 2, z is equal to 1, and this automatically satisfies this equation. That is not an issue, but for our own verification purpose, that what the process we have used for Gauss elimination method, we are in the right manner, we can check it in the given system of linear equation, that if we substitute 3, 2 and 1 in this system, I think all of you will get that it is satisfied. That is 3 plus 2 into 2, 4 plus 3, that is 10. In the second equation, we can substitute 3. So it will be 18 plus 2, that is 10, that is 28, plus 2, that is 30. And in the last equation also, if you substitute the values, you will get it is satisfied. So we are now getting the system solution of the system of linear equation by Gauss elimination method. So finally, what I want to say, that you must use this reference for your practice and for making your conception more clear, as well as that is a sample problem in the form of assignment. Please solve this one. Thank you all for your listening. Happy listening, happy learning.